So hello everyone. Thank you very much for being here for the live coding session of Aurélien. So Damir also is there. So the core team is going to make you an introduction to the connection from smart contracts to dApps. And just for you to know, so Aurélien at the end will pass the links, if you need any access to any repo. And if you want to try by yourself. And also, if you have any questions, just ask them in the chat. No worries. At the end, I will take the questions and I will forward them to Aurélien, so he will answer at the end of the presentation. Also, just for you to know, it's recorded. So if you don't want to speak at the end, for example, just you can type the questions, so it will stay anonymous. So let's start. I give you the place, Aurélien.
Okay, hello everyone. So my name is Aurélien. I'm core developer at Massa. I'm working on developing the nodes that you run each testnet. So yeah, I will present you how to. We will start by doing a simple smart contract, like he's doing really simple things, and connecting it to the web interface. So I will code it in the first place in plain.js. And after I will show you a code in React.js for those who are familiar with React. So I will start right now. So we are developing a lot of tools at Massa. Some of you maybe saw them in the presentation of the innovation team yesterday. But one of our biggest tool for developing smart contract is a tool that is called Toolkit, which allow you to make like a big ID, like full deployment of your smart contract. So for example, you just can create your repository with the single command that we will run just after. And after you can like deploy your smart contract on the blockchain, test it with unit test or with a local tester. So it's a really useful project. And so we'll start by using it. So I will run the command that I just show you before. So it's npx. For some of you that are not familiar with it, it's a command from Node that allow you to run command on package that are on the web. So I will run the package on the Massa SA toolkit. I use the specific version because it's an update for this testnet that has not been released yet, but that will be released in the coming days. And I run the command init to initialize my repository. And after I give the name that I want, is the same command as when you want to create React repository, for example, with a React create app. So I create my repository and let's wait a bit. Okay, it's tell me that it's fully created. So I will open my VS Code and see that I have a smart contract folder with a lot of things in it. And I have a README that explains me a bit how it works, but I will explain you myself so that we will go more faster. So the main repository that we are interested in is the assembly repository that contains the source code of your smart contract. So it's here that you will write all you need about the smart contract. So yeah, there is an example with a function that stores some data and a function that print an event, but we will write our proper code just after. There is a deployer that allow you to run directly your blockchain, your smart contract on the blockchain. And there is also a simulator that allow you to test in local. We will not run it in this call, but if you want, you can play with it on your side. Okay, so the smart contract that I will develop today to be really simple is a smart contract that have a storage with just one key, which is the name of a person, and his age as a value. So just a mapping between the name of someone and a value of someone, an age of someone. So I will start with the first function, which is a function that I will use to initialize my my storage. So in Massa, to store data, we use storage that has the format of a map with key and values. And so I can interact with it using the function that are provided by our library, which is Massa ASSDK, and they are automatically imported when you use the deployer, the SA toolkit, sorry. So for example, I can just say that I want to store I want to store in a value in the key Alice, for example, which is going to be the name of my my testing person. I want to store her age. So there is multiple things to note. The function to store data on the data store used array of bytes. So if you want to store, for example, a string, you have to transform it in bytes. That's why I use 2 bytes function. That is a function that we provide in our library also. And the value is also encoded as byte array. So you can also, for example, just put an array here directly like that if you want, but we will not do it like this way, because we also provide a way for you to serialize and deserialize the data that you want to store on the storage. For example, if you want to store a string, you will not write all the characters with the numbers here. We provide you a structure that is called args. So I will initialize it. It comes from Massa SDK also. And so you can pass data to args. So for example, I can add the age that I want to give to Alice, which is 1, because she is 1 year old and she is very young. And so we can store this data on the data store using the method serialize of the arg structure. So to work through each line that I wrote here, the first one creates an arg structure, which will allow us to serialize and deserialize complex data to store them in the storage. The second one, I store the number 1 in this serialized structure. And the third one, I store the age of Alice in the storage using a key and a value map. That will be my initialize function. And after, I want to make a second function where I can pass the age of someone, and that it will store it in the data store. So I will write a function that I will call set age. That will return nothing. And so this function will have arguments, because I will pass the age, and arguments in Massa are always of type array of bytes. So the same type, as the array that you store in the data store. So all arguments should have this type. But we also use the arg structure to deserialize the data we pass in the array of bytes to use them in your code. So I will show you an example. I can initialize like before the structure args, and this time I give him the parameters that I just get from the line just up this one, from line 10. If you see, yeah, you see the line. So from line 10. I will call this arg struct, and I can just say that I want to deserialize using next function the next unsigned number that is encoded in the array of bytes, and I will call it, for example, age. So now I have the age that is passed as parameter as a number, and I can set it in the storage of Alice. So I can use this to store. Oh, okay, yes. To store, I need to create a new args function just to store the code in the storage of Massa. You need to encode it in array of bytes. So I need to create another arg structure to encode my age. So here I'm just doing like decoding and re-encode it. It's not very useful, but I will just make some more complicated thing, not really complicated thing, but some more useful thing just after. So here I can like store the age encoded that I decode just before. So yeah, to explain line by line what I have done here, it's like you create an arg structure to deserialize the arguments that are passed to your function. We'll see how we pass this argument using the web just after, because just after you will see that we can call those functions from the web, and that will be the part that is the most interesting. So the argument will be serialized in a byte array. And so I deserialize it in the first and second line. And in the third line, I serialize it, again, to store them in the data store. I can choose to have more data passed in parameters. For example, here I just assume that I have an age in parameter. And I can say that also I will have a name in parameter. So I will use the arg structure to decode a name as a string. So right now I have like my structure args. I assume that you have a name as a string and an age as a number. And I can use this name just below instead of Alice to store the data in it. So that will be, I will just rename my function to match the rest of the code. That will be the only part of the smart contract that will code. If you didn't understand all, it's not a problem for the rest of the call. I will just explain the web part, but if you were interested on how to code the smart contract, that's it now. Just you can keep in mind that this smart contract has two functions, one to initialize the storage and another one to change the value of the age in the storage. And these are the functions that we will call from the web. That's the only thing that you need to keep for the rest of the code if you want. So to deploy my smart contracts on the blockchain, I can use the deployer that is included in Massa toolkit. So if I check the README, I can see that if I want to deploy a smart contract, it's right. Yeah, if I want to deploy a smart contract, I need to have a .env file with the following values, and after I can just run npm run build and npm run deploy. So in the .env, I need to have a private key. So what is this private key for? This private key is just to have coins to deploy the smart contract and to have an account that will be the one that will deploy the smart contract on the blockchain. So there is a .env example here that we can just rename .env, and we will import a private key. So I will just take my private key that I prepared. It's not my real private key, of course. I will go in my Massa client. Just maybe you are familiar with the Massa client to get my private key. Okay, I don't see anything with Zoom. Okay, so I have a private key here. I will use it in my .env right there. And after I can just like use the npm run build to build my smart contract. So I will go in the smart contract folder and run npm run build. It compiled well. And after I can just run npm run deploy, and it will deploy the smart contract on the blockchain. So this part is really, really simple. Like just if you know how to write smart contract, the deploy part is really easy. You just have to run one command and just put npm run deploy, and it will deploy your smart contract on the blockchain. So right now we are waiting for the smart contract to be deployed and for it deploy as final on the blockchain. So we just wait a few minutes, and we will have the address of the smart contract that will be displayed on our terminal, and we can use it in the web part that we'll just code just after. Okay, so I have it right now. I can't see it because there is the Zoom. How I can remove this? I don't know. I will just, okay, I have the address right there. And so I will be able to code some website using it. So I have set up a simple HTML file where I will write my code. So I can just open it in Google Chrome. So I will open it right now. So here it's my my website. It's totally empty because I don't code anything yet, but we will code it together. So the goal is to interact with the two functions that I wrote before. So the function that initialized the smart contract and the function that set the age. So we will write, for example, a little text with Alice and her name. So this is basic HTML, but if you don't understand it, like here in this line, I'm I'm defining like something to write on the website, which is Alice and her age that will be override by our JavaScript code just after. So if I refresh on my browser, I now have Alice written. And I will also have different buttons. So the first one will be to increase the age of Alice. Maybe the second one to downcraze. And maybe one to initialize, called the initialize function. And also one to reload, to fetch back the data on the blockchain. I will just explain it after. So this is like the basic HTML. If I refresh my, I will just save it. If I refresh on my browser, there is the buttons here. And so we will use these buttons to interact with the smart contract. So to interact with smart contract and the whole blockchain in general, we have coded a package that is named Massa Web3. And I have a pretty big README, and there is everything in it. So for example, we want to use it in a basic HTML file. So there is like the script balise that we can use, but we can also use it in React, in Node.js, in Vue.js, in whatever you want. So we will, for this call, we will use it in plain.js. So I will just take the line and put it in my script, just at the top of the body. And if you see in the script, yeah, the age variable, the one question from the chat is the age variable that is stored on the storage will be possibly retrieved from the website. Yes, it will be something that we will show. The age variable here will be the data that is on the blockchain. So that's the point we will code just after. So here we can we have to set up a version of Massa Web 3. So the last version is 1.11.0. And so I will also import my script that I will write just after. So I have already set up a file in a folder in a folder named JS, and I have a file named index.js where I will write my code in JavaScript. So if I check a bit the documentation on how to use the Massa Web3 on JavaScript, you will see that you can just use window.massa and you will have access to everything. So I will try it. If I put console.log window.massa, and I just check on the console on my browser, I refresh. And I will see that I have an object here with a lot of different sub-objects and a lot of function. Everything is explained on the README. Here you have every function, every sub-function with examples in React, but in TypeScript, but you can just use it in JavaScript by removing the types. That's the good thing about JavaScript. It's more easy to go from TypeScript to JavaScript than the contrary. So for example, at the start, we will need to set up a basic account. So I will just copy paste the code that is said how to create a basic account, and I will paste it on my script. So I remove the types because I don't want to make TypeScript, just want to make JavaScript. And as you can see, the function that is used by the library are asynchronous. So if you want to make something more synchronous, you can just define a client that will be null and have a function that will be init client, for example. And in this function, you put your async code right there. And just, and we will set up that we don't return client, we just say, yeah, we just say that client, okay, no, I say cheat. Okay. So the function is asynchronous. So we will just use the promise system of JavaScript to store the client created in our client variable. So just make this. I will explain this line just after. It's complicated to code and explain at the same time. So yeah, so we are creating a default client for Massa, and after we will store this client in the client variable just there. So, for example, if I print here the client, there will be my Massa client. I will just check if I. Okay, so you don't know client factory. So yeah, everything is in the window.massa variable. So we have to write each time window.massa. Oh, my VS Code is doing things. Okay, and here also we have to use window.massa. If you want, you can also create a variable called Massa and just use it in the rest of your code. This is for plain JavaScript. For React, it's more easy, and there is more implementation with React. But for plain JavaScript, you have to use the window.massa object. I will show you the example in React just after. So yeah, here we have all the methods that we can call. So we have the public API, for example, with a lot of methods that are all documented in the README, and we will use it to retrieve the data. So I have a client. I can now use it to like initialize my smart contract or retrieve the data on the blockchain. So the first thing I will do is I will code a function to retrieve the age value on the blockchain. So I will name it getAge, for example. And I will use the client that I just created before to interact with the blockchain. So let's check the documentation, how I can do that. So I want to get like the content of my data store. Okay, I can see in the documentation that there is a function that is named getDataStoreEntries, where I can like show, or I can fetch for an address and a key the value in the data store. So it's perfect for me because I have the address of my smart contract that I need to save just after, and the key, which is Alice. So I will just take the smart contract address that I created before here and put it in a variable so that we don't forget it. Okay, so I can use the client with, so I will copy paste the command and we will change it to match what we need. So client public API get data store entries. We remove the types because we don't want them because we are doing JavaScript. Exactly, Massa Web 3 question from the chat. Massa Web 3 is a library to develop on the web like Ether.js or Solana Web3.js. But the Massa is not VM compatible. We have our proper way to write smart contracts, which is in assembly script and use the storage feature that I just showed. And so it's like the same library as the other blockchains, just this one is designed for Massa and have the features that is needed for Massa. But yeah, it takes inspiration from the others one to not lose every developer that want to switch to Massa. So yeah, let's get back to my code. The secret key in the plain.js file is not a problem. So here it's not a secret key, it's a smart contract address that needs, it's like if you want to interact with the backend in normal development, you will need to write the URL that you will call on your API, for example. And here you have the URL of the testnet. So we have defined the constant to avoid you to rewrite it each time. But you also have the address where you want to to collect data. It's like if you have an endpoint on an API, you can see it as the same way to interact. So it's not a confidential data, it's just an address. At the top of the file here, this is like an account that needs to be set to use the Massa client, but you can, for example, avoid writing the secret key here. It's just more complicated, and I will not show it right now because it will lost everyone. But yeah, you can definitely use another feature to hide it. If you have someone is asking if I have a smart contract on BSC, can I deploy it on Massa? No, because Massa is not EVM compatible, so you will have to rewrite your smart contract in assembly script. But the thing that is cool is that assembly script is close to TypeScript, so you can just learn some JavaScript and TypeScript, or maybe you already know it, and so you can develop on Massa. You don't have to learn Solidity, for example. Is there a limit for object that can be stored on the storage on the blockchain? Yes, there is limits because when you want to store objects, you will need to have coins because coins will be locked for the storage. And when you release your storage space, you have your coins back. There is a documentation about it in our docs, which is named storage costs, and you will have everything explained in detail there. Clearly it's as say Adrien, in the real world you will use a wallet. I will show you a wallet that the community made at the end of the call, but here is just to showcase and to go more faster. So let's back to the code. I want to get like the key of the data store. So my key is Alice, but it's encoded in bytes. And from in assembly script, the string are UTF 16. Yes, UTF 16. And so you have to encode the string in UTF-16. So we will make an helper function in Massa Web3 later on, but right now we don't have. So I will just check the function that I wrote just before the call. And this whole example will be available on our repository after the call. So I will send you the link. Don't worry if there is like shady things that I'm doing and you want to take more time to understand them. So this is a function that just encodes a string in UTF says in a byte array. So that I can just write str encode UTF 16. And here I put my key. So my key will be Alice, sorry. And my smart contract address is the smart contract that I save in the SC address variable. I will just put it there so that we can all see. So this function will return the age. It will fetch the age, sorry, but it will not return it. So we have to, like when we fetch this, we have to use the .zen to make something when the call has successfully resolved. And in this Zen function, we will use the result of the call. It's like it's very similar on how do you develop when you're using an API. That's the cool thing. It's like you are not lost. It's like if you use something, like a REST API in your daily development, it's nearly the same thing. So here we have the result. We can print it, and we will see what it contains. We need to call this function on our HTML. So I will say that on the reload button, we will call this function. So when we click on the reload button, we will call the function getAge. And let's see what happens if I click on my website. If I click reload, I will have some data here. So we can see that we have the result for the key that I asked in index 0, and the value are nulls because I didn't initialize my contract, but we will see just after how to initialize it. And so now we can put this value in the age variable on our HTML so that it will be displayed on the browser. So to do that, we can use JavaScript code, which is, for example, document get element by ID. And we can put like the candidate value here. Okay, so it should be nice. Okay, so here it's don't write anything because the value are not initialized, but we will initialize them just after. Gotcha. A question from the chat. Wouldn't reasoning storage, I think someone commented. Yeah, so the question asks if we can release the storage, will it affect other smart contracts that rely on it? So yeah, the question is a bit advanced, but it's interesting. You can set up something that your smart contract only have access to your storage. The other smart contract don't have access to your storage. They have access in read-only, but they can't write it. So it's you to be careful that you're not overriding the storage, and it's you that when you want to use a smart contract to be careful that this smart contract doesn't override the storage and delete it. It's like you have to check the source and trust him, I think. But it's more of a set question. Yeah, just let's back to our code. Now we have a reload button that allows us to fetch the data from the blockchain. So we can directly fetch it in the storage, just like if we fetch it from a database in the backend. It's the same thing. But we want now to have this button that will call our function initialize on the smart contract. So let's check on Massa Web3 how we can call smart contract. So let's scroll a bit the documentation. I know where it is. I'm doing like acting things, but so that you can see. So the call is, oh, I know, but I don't really know maybe. So, okay, smart contracts, read and write calls. Smart contract, call smart contract. Perfect. We have a function that allows us to call a smart contract. We can see that the parameter are the fee. So it's like the fee that you want to put for your operation to be included, the gas, the coins, the address, the function name that you want to call, and the parameters. So let's go for it. Let's copy paste it and use it in our code. So I will create a function that I will name initialize, for example. And just use my clients. So my client, and I remove the types because I'm not doing TypeScript. And so I have to specify the fees, the max gas. I will just put a bit more to be sure. I will give some coins to my smart contract so that he can store data because it's a smart contract that pay for the data that is stored. I will send him like 10 Massa. So the units here it's in a nano Massa, I think, something like that. 10 minus 1, power 10 minus 1, power 10 minus 9. Yes. So this 10 trillion will just be 10 Massa token. And I want to call the function that is on my smart contract address, and the function name is initialize. And the parameters I want to give him are empty. And so the parameters, as we saw just before, are encoded in bytes array. And so if you want to pass them, you have to use the arg structure. So the arg structure is also on Massa Web3. So you can just define a new Massa, Massa.args, and use this structure to encode your parameters and pass it to the function. So in this case, there is no parameters. So we can just put args.serialize with an empty args. But we will see that when we want to increase the age with the other buttons, we will have parameters. So maybe we can print the result of this function also to be sure that it works. Let's see. So we will call this function on the button that is written initialize. So we'll add a non-click version, a non-click function call. Let's check on the browser what it's doing. So if I click initialize, I will have an operation ID that will be displayed as the result of my call. So the console.log that I wrote before show an operation ID, and this is the operation ID that is sent to that represents the operation that is sent to the blockchain to interact with the smart contract. So now, if I click on reload, I should have the data of Alice, but maybe it didn't work because I don't have it. Okay, I think I know what's the problem, because I think I don't have enough tokens on this address that I just put here. So just I need, as I'm sending coins through the call, yeah, I'm sending some coins. I need to have coins on my address. Yeah, otherwise it will not work. So yeah, the secret key is in the file, but you can imagine, for example, having a wallet instead of this this private key written directly in the file. So let's try again with this. If I call my initialize again, I can use this operation ID to check if everything works well using the Massa client. If you want, you can get the events, and if there is an error, the events will be popped. So yeah, there is an error. Unexpected number of parameters in the function called. So let's see, what did I do badly? Okay. So they say that maybe, oh, okay, I think I need to add parameters even if I don't use them. I think that's the problem I made. So for example, here I spot an error on my contract. So it's cool, so that I can share how we can update easily the contract on the blockchain. So not update, but deploy a new one and use them in the HTML file. So I made a modification on my smart contract. I can rebuild it using npm run build and redeploy it, and it will give me a new address where there is my new version of my smart contract, and that I can use to call in my website. So let's wait a bit that the deployment happen. It should be very fast, I think. Maybe like less than 1 minute, because we are waiting for finality here. We are not waiting only that the operation in the block, we are waiting that the block is final before sending the address. So it takes a bit of time here. Okay, so we have it perfect. Let's use it now in our GS file, and just I need to change my address here, and the rest of the code will work with the new address. So it's really, really simple. So I try to initialize again. I can check with my Massa client if I have some problems. I can also set up something on the web to have the events directly on the web, but it will take too much time for today. So I haven't any errors, so I can think that maybe the data is stored. I will try to reload it. And so I have the data here. The only problem is that I have the data as a byte array directly and not the data in number. So in order to have the good data, we can use the arg structure to deserialize this byte array. So this byte array is basically a number in 4 bytes that have the value 1, and we can use the arg structure to deserialize it. So I will just use a new args, and I will use the function which is called next. The documentation is in Massa Webflow also, but I will not go through this. It's the same function that you have in the smart contract world. The both functions are the same. So we can call this variable, for example, age. And in the args parameter, we want to put the value that we want to decode. So the value that we want to decode is this one. And after we can put age here. So now, instead of directly displaying the result from the blockchain, we are using the arg structure to deserialize it and use it as a number. So let's check if it works better. I can just reload now because I have already initialized the contract, and the contract stay always on the blockchain. So I don't need to reinitialize each time. And so now I can just reload, and we can see that Alice have 1 year. We will just code one function to increase the age of Alice, and it will be like a good start for you to play with it if you want in the future. And after I will show you some resources also that can be useful for you. So the function, we can call it, for example, increase age. And so we can use the same like skeleton from the previous function that initialized the smart contract. But instead of calling the initialize function, we will call our function that is named change age. So we call the change age function. And this time we need to pass a few parameters. We need to pass a string for the name. So in our case, it will be Alice. And to pass a number for the age. So we will create an R structure that is already there. And so we can use the age. So we can retrieve the age from the HTML code. And now we can encode it. So we can add a string. If I remember well, it's, yeah. I will add Alice, and also in my args, I will add an age +1. I will add an increase of the age variable. And so right now I send the arguments as parameter to my function, and this function should call the smart contract and increase the age. We can check it with our browser. Just we need to say that the button will call this function. Increase age. Okay, let's try. So I press increase age. It's show me an operation ID because the operation has been done on the blockchain. We can wait like few seconds because the time that the operation is included in the correct thread. So in few seconds we will hit the reload button. I can start hitting it and pray. Oh, okay, no, I just send a new operation somewhere. So yeah, we can start reloading and pray for the age to increase. If it don't increase, it's like a shame for me. It increased, but it increased by by too much. It's now 11. Oh, maybe it's not. It's encode. That doesn't work well.
You need to add the parse int around the inner HTML.
Yeah, yeah. We will use big int for this because it allows to parse directly the int, and so we can. Yeah, we can directly use begin. So begin will parse the HTML that is considered as a string, as we can see here, and it will transform it in a big integer that is recognized by args to serialize. So we can make a new one. So if we reload here, we fetch the data from the blockchain, we increase the age, we wait a few seconds, and we can reload, and we will have like the age increased. Let's pray. Yeah, let's go. And so after we can, for example, write a function that will downgrade the age. We will not write it here because it's like the same as this one, but instead of +1, it's -1. And that's a basic code that allows you to fetch data from the blockchain and call smart contract from blockchain that will interact with the storage, and after you can refetch the data. For example, you can have, instead of the reload button, you can have something like a set interval that will allow you to fetch on a regular basis the data. You can also use pooling events or things like that. Here I showed a simple example. I can show you also the code that I wrote just before the call, the same code, but in React for those who are interested in. So this is like an example of usage of Massa Web3 in React.js. So as you can see, you can define a client for those who know and set it using the same function that we used on the plain JS one. And after as you can see, there is the same functions, but in React. So the library is totally the same between the two environments, which is really cool to have compatible things and to check codes in both languages and maybe rewrite them in the other. And here we have the buttons that will call the function. So yeah, it's just something better here. It's that it's in TypeScript. So you have more completion with your code editor than plain.js. But the website in plain.js is way lighter. And so you can, for example, store it on our decentralized web, which I will not show it right now, but has been shown by the team yesterday. Something else that I want to show you is that someone asked about the secret key that is mounted on the file. So yeah, maybe it's better to use a wallet. I just want to make some promotion to a wallet that has been coded by the community, and that is pretty well. So this wallet is called Beerbuy. It's a wallet for Massa, which have the same interface as MetaMask. And you can basically use it very simple in React in plain.js also. You can, for example, if you want to use it in React, you can just use Beerbuy, and you can clearly use the wallet, which will have all the information. You can sign transaction, etc. So they have made a cool job, and it's not one official from Massa, but it's something that is developing by the community right now. Let's see if they maintain it, but shout out to them. It's really useful wallet. Other things, I think I have showed everything. If everyone has some more questions that I didn't ask during the presentation, or if something was unclear and it's still explainable in this call, do not hesitate to ask. Maybe I have been too fast on some things. But otherwise, it's really a simple example. Yeah, you can find this example on Massa Labs, the Massa SC examples repository. So it will be there just after the call. You will have a folder named age, and in this you will have all the code that I wrote during the call with the example in React also, so that you can just take it if you want and tweak some code, add some features, and try on your end and see if you want to push it more and try by yourself. So I don't see any more question. Maybe if there is no question, I think we can.
Yeah. Also, if you have questions, as you know, Aurélien is always answering the community and builders and so on. So don't hesitate to ask questions on the Discord as well. When he has time, of course, he can't always answer the question straight away. And also we will and we will publish the video also on YouTube. So also if there are comments, I will forward them to Aurélien to answer the comments in the YouTube video if needed. Yeah, I hope this tutorial is going to be helpful for everyone who wants to develop on Massa. Not only people who are here, but also people who are going to develop in the future. And I don't know if you want to say a word as well, Damien, but I wanted to say thank you very much, Aurélien, for the presentation and the tutorial. Quite amazing. And I will also post the links for the builders when I will upload the video, the same as the innovation team video that we did yesterday.
Yeah, it was a bit technical, but if you are a developer that want to be involved in Massa, it will be like the tutorial for you, and you can just check the replay on YouTube and put me in slower so that you can understand much better. So yeah, if you have any question, write them on the comments on YouTube. We will answer it.
So if it's all, thank you very much, everyone. Thanks for everyone who was there. Thanks again, Aurélien. And let's stop the recording. Tac.
Problem.